Now let's talk about some concyclic points. This is what we were talking about when we were talking about definition of a circle. We said for a definition of a circle, we need 3 points. But if 4 points are given, they have to be concyclic. If points are given, they have to be concyclic for a circle to be drawn through them. And how do we verify if the points are concyclic? We take any of the 3 points and derive the equation of circle for the 3 points. And then we will now put the 4th point. We test it through that equation. If it gives the answer that we expect, either 0 or equal to the radius, it means all the points are concyclic. For instance, 4, 3, 2, 1, 0 minus 3. We have used that one to get our equation before. And the equation is x minus 11 squared plus y plus 6 squared is equal to 130. That is the radius squared. Now, since we have used these 3 points to get this equation, for us to know if it is concyclic now, that is, this one also passes through that, is also a point on that circle. We will now put it there. 5 minus 11 squared plus 2 plus 6 squared. That will give us minus 6 squared plus 8 squared. And that will give us 36 plus 64, which is 100. So it means that the points are not concyclic. So that's how we test for concyclic points of a circle. Now let's talk about verification if a point given is inside or outside a circle. We have an equation for a circle like this. I want to verify if points A, 1, minus 1, and B, 5, 2 are inside or outside the circle. All we need to do is to substitute the x coordinate for x, the y coordinate for y. And if it gives us the final answer, it means it is on the circle, it is concyclic. But if it gives us less than what we expect to have, it is inside. If it gives us more than what we expect, it is outside. Like if we do it like x minus a squared plus y minus b squared plus y minus b squared, whatever, is equal to r squared. If on substituting the x coordinate for x and y coordinate for y, and the answer you get at the end of the day is greater than r squared, it means it is outside the circle. If it is less than r squared, it means it is inside the circle. Now, let's work out this equation, this question given to us. It's a very simple thing to do. We have these points 1, minus 1. Let's test if it is inside or outside or even on the circle. We put this one 1 plus minus 3 into 1 plus 4 into minus 1 minus 12. It gives us 1 plus 1 minus 3 minus 4 minus 12, which gives us minus 19. This is less than 0, so it means it is inside the circle. For the other one, let's test. That gives us 5 squared plus 2 squared minus 3 into 5 plus 4 into 2 minus 12. That's what it gives us. 25 plus 4 minus 15 plus 8 minus 12. This is 25, 29, 37 minus 27 is greater than 0. So this point is outside the circle. So that's how to test if a point is outside the circle. We have already tested if all points are on a circle. Now, let's talk about tangent to a circle. What we mean by tangent is a line that you just touch the circle and do not pass it through the circle. You just touch a point and cross over. Tangents, understanding tangents in relation to circle is very important. We can solve so many things through understanding of tangents. Even not only circle, to curve generally. Now, if you look at tangents, let's say this tangent and this point T. We know the one thing. A line from the center to the tangent will be perpendicular to each other. So this one is referred to as the normal and this one is the tangent. Another thing is the distance of the tangent from the center is equal to the radius. The distance of the tangent, the perpendicular distance from the radius will be from the center will be equal to the radius. So that is very key in solving so many questions in circle problems. Now let's look at a situation where we are given the equation of a straight line and we are asked to verify if it's a tangent to a circle or not. Let's do this little exercise. Verify if line 2x plus 5y plus 11 equals 0 is a tangent to the circle x squared plus y squared plus 2x minus 8y minus 12 equals 0. He has said something that the distance of the tangent from the center should be equal to the radius and at the same time should be perpendicular to the radius. But since radius can move through 360, the tangent of the circle too can have as many gradients as possible. Now, to verify this, the first thing is to find the center of this circle. Let's go. So we do that by saying x squared plus 2x plus y squared minus 8y minus 12 equals 0. Okay, so computing this one gives me x plus 1 squared minus 1 plus y minus 4 squared minus 16 minus 12 equals 0. So I have x plus 1 squared plus y minus 4 squared minus 29 equals 0. So I have x plus 1 squared plus y minus 4 squared is equal to 29. So from this, we realize that the radius is equal to root of 29. And the center is minus 1 and 4. We have our equation of the line to verify this tangent to be 2x plus 5y plus 11 equals 0. And recall from the equation of straight line, the distance from a point to the straight line, that is distance from x1, y1 to the straight line will be 2 into x1 plus 5 into y1 plus 11 over square root of 2 squared plus 5 squared. So in this instance, our distance will be equal to 2 into minus 1, that is minus 2, plus 5 into 4, that is plus 20, plus 11 over root of 29. So what does that give us? It gives us 29 over root of 29. So which is root of 29. So from here we realize that the distance of the center minus 1 4 to this straight line is equal to root of 29, and the radius is also 29. So the radius is equal to distance of center from line. So, and when we are talking about this line, it's the perpendicular distance. Therefore, line is tangent to the circle. The line given is a tangent to the circle. Now let's talk about finding the tangent, the equation of tangent to the circle at any point. General equation. Let's just derive the general equation to make it easy for us to work on it. You know, when we want to find the equation, since the tangents are straight lines, all we need to do is to work on it as if we are working on a straight line. We are getting equation of a straight line. And to get equation of a straight line, you need 1, the gradient of that line. 2, the points, any point on that curve or on that line. Now let's get the gradients of this line, of the circle at the points. Yes, let's get the gradient of a straight line that will touch the circle at a point. Let's say x, y. Let's x1, y1. Let's make it like that. And we know that from this point we have minus g minus f. And this one is the r. And this one is perpendicular. So these are our tangents. Let us find the gradients of this radius. So gradient of radius that contacts the tangents is y1 plus f over x1 plus g. That is m1. Now, the gradient of this tangent, since it is perpendicular to this one, will now be m2, which is equal to minus 1 over m1. Remember, m1, m2 will be equal to minus 1 if the lines are perpendicular to each other. Therefore, m2, that is gradient of tangents, will be equal to minus 1 over y1 plus f over x1 plus g, which is equal to minus x1 plus g over y1 plus f. That is the gradient of the tangent. If you are well grounded in calculus as well, just basic calculus, what we need to do is just to differentiate this, and then we'll get the tangent at this point. So to differentiate x squared plus y squared plus 2gx plus 2fy, we are going to get 2x plus 2y dy dx plus 2g plus 2f dy dx is equal to 0. So this is how you get dy dx at that point. And dy dx happens to be the gradient of the tangent. Now let's divide through by 2. That will give us x plus y dy dx plus g plus f dy dx equals 0. What next? We gather terms containing dy dx to one place and the one containing that does not contain dy dx to another place. So we have minus x plus g is equal to y plus f dy dx. Therefore, dy dx is equal to minus x plus g over y plus f. So the same thing. So that is the way to go about that. In this instance, we won't need to first of all get the center, or using the completing the square method to get the coordinate of the center if you use this. But if you use this, you will need to do that unless it has been factorized already. Now let's go straight to applying this to get equation of the tangent. So you might just get it straight right from the equation. Now our gradient is minus x plus g over y plus f generally, but at points x1, y1, and or dy dx will be equal to minus x1 plus g over y1 plus f. So since we have these points, we can now use it to find our general equation for the straight line. The line will be, any point on the line will be represented as x, y. So the equation of the straight line will now be y minus, since you have a point now, y1 over x minus x1 will be equal to minus x1 plus g over y1 plus f. So let's cross multiply. So we have y minus y1 into y1 plus f is equal to minus x1 plus g into x minus x1. We can also write this as x1 minus x into x1 plus g. Now, on expansion, we have y1 plus yf minus y1 squared minus y1f is also giving us x1 squared plus x1g minus x1 minus xg. Okay. Now let me collect the terms with x1, y1 to one side and the terms with x and y to the other side. Now I have, so I gather the y, anything with y and x to this side, and anything that comprises only y1 and x1 but does not include x and y, I gather them to this side. Looking at this equation now, we have x1 plus y1 squared plus y1f plus x1g. If you look at it, since this point is on the circle, it's still a little bit, it has some things to make up the equation of the circle to be equal to 0. And what is that thing? If you compare this one, we have x1 squared, y1 squared, we have y1f. So which means that if we add y1f here, we have 2y1f. If we have x1g, we have 2x1g. And if we add c at the same time, everything here will become to 0. So if we add the same thing to both sides, for integrity of the equation to be maintained, we are going to have something sensible. So let's add x1g plus y1f plus c to both sides. And what will that give us? y1 plus y1f plus yf plus x1 plus x1g plus xg plus c will now give us x1 squared plus y1 squared plus 2y1f plus 2x1g plus c. And if you look at this, it's the same thing as this. It gives us 0. Now, if you look at it, everything at the end of the day becomes x1 plus y1 plus f into y bracket y plus y1 g bracket x plus x1 plus c equals to 0. What is that saying? If you compare it to the circle equation, x squared plus y squared plus 2fx plus 2gx plus 2fy plus c equals to 0. It means we are taking one of this x and replacing x with x1 and one y with y1. So if you look at this x squared becomes xx1. This y squared becomes yy1. This gx, 2gx becomes g into x plus x1. This 2fy becomes f into y plus y1 plus c equals to 0. So you can just do this one straight, especially with this multiple choice question. Now let's treat length of a tangent from a point T x1 y1 to the circle. How do we get this quickly? We have something like this, and we have T, and this is the center. So let this place be x1 y1. We know that this place will be, let's say P, let's say this one is C, center, and we have this place as minus G minus F. This place is R. From our knowledge of distance, the length of the tangent Length of tangent is CP. Radius R, PC. And we have another length, TC, and which is, using Pythagoras theorem, TC squared will be equal to CP squared minus R squared, or PC squared. And the equation of our circle is x squared plus y squared plus 2gx plus 2fy plus c equals 0. Let's put that in mind. And our radius is equal to g squared plus f squared minus c. Let's also put that in mind. Now, we know what our CP squared is. CP squared is equal to TC squared minus R squared. Let's look at what TC squared is. TC squared is equal to x1 plus g squared plus y1 plus f squared. That's our TC squared. And our TP squared is this one minus R squared. So CP squared is equal to TC squared minus R squared, which is equal to x1 plus g squared plus y1 plus f squared minus g squared plus f squared minus c. So let's expand this. We have x1 squared plus g squared plus 2x1g plus y1 squared plus f squared plus 2f(y1). Minus g squared minus f squared plus c. And what is that going to give us? It's going to give us x1 squared, this one we cancel this, plus 2g x1 plus y1 squared, this one we cancel this, plus 2f y1 plus c equals. So if you rearrange it, you will see that for the length of the tangent, it's just replacing the coordinates in the equation of the circle, plus y1 squared plus 2g x1 plus 2f y1 plus c. That is the length of our tangent from a point external to the circle, the point C, x1, y1. So with this, you can be asked, what are the points at which the tangent will cut the circle? With this, you have up to 3 equations to get. A tangent from point T, it can cut the circle at P here, it can cut the circle at point P1 up there. And we can, using all this information, work out those points at which it touches the circle.